As I mentioned in the previous video, a vector autoregression model allows us to have a vector of not just two time series, but actually three or more. But let's have a more detailed look on it. So vector autoregression, this is a set of k time series regressions in which the regressors elect values of all k series. So if you have k number of series, so k number of variables, you should have k number of regressions. And this type of a model extends the univariate autoregression to a list of vector of time series variables. But in this example, you can see there are only two equations, where y is a function of two left values of itself and two left values of x, and x is function of two left values of itself and two left values of y. And as you can see, since the number of legs in each of this equation is the same, there are two legs of y, two legs of x, two legs of x, two legs of y. The system of equation can be called as vector autoregression of the second order, or it can also be denoted as VAR2. And to analyze vector autoregression, let's consider an example. Suppose you've got time series data on the Canadian money, M, and interest rate R, for some period from the first quarter of 1980 till the fourth quarter of 1987. And now suppose you would want to find the bilateral causality. And now suppose you have found bilateral causality between the two variables using the Granger test. And in this case, we can apply the vector autoregression analysis. So from this system of equations, you can get that money supply is a function of its own left values and the interest rate, the legs of interest rate, and the interest rate is a function of the left values of the money supply and the left values of the interest rate itself. The most important question before we estimate this model, how should we choose the leg length? So the number of k right here. And the same, similar to the case of Granger test, we have some techniques, some tests that allow us to choose the leg length, and this is Akayik and Schwarz information criterion. Actually, there are more of them, but those are the most famous ones. And after you estimate the model, for each model you need to estimate this criteria, and the model that has the lowest information criteria should be chosen over the other models.